Hello and welcome. Today we want to find the eigenvalues and eigenvectors of a 3 by 3 matrix. So we have our matrix here 1 0 3 2 3 2 3 0 1. We want to find the eigenvalues and the eigenvectors. The first thing will be to get the characteristic polynomial, and after getting the characteristic polynomial we will get the characteristic equation. So we have, let's write here in short, characteristic polynomial. And now we are getting, we will have lambda I minus a equals to p, which is our characteristic polynomial. This simply means lambda I minus a, and a is our matrix here. But now these signs are used to denote the determinant. So we are going to get lambda I, but now if this we equate to 0, it becomes a characteristic equation. So we are going to proceed. We will have lambda 0 0. The diagonal is lambda, it's a diagonal matrix, minus 1 0 3 2 3 2 3 0 1 is equals to 0. We'll go ahead and get lambda minus 1 0 0 minus 3 is negative 3, and then we will have negative 2 lambda minus 3 negative 2. We will have negative 3 0 lambda minus 1. So let's just do that again. We will have lambda minus 1 is equals to 0. So we need to get the determinant, and now for our determinant you check and see which row will be easier for you to use. So in my case I'm going to use row 2. If you're using row 1, we will have plus, negative, plus. Row 2 will have negative, plus, negative, and then row 3 will have plus, minus, plus. So I'm going to use row 2. And as for row 2, we are going to use the cofactor method. So since row 2 is our main concern, you cover the second row and the first column. We will get negative 2 into, you will discover that we have 0 negative 3 0 lambda minus 1 plus lambda minus 3. Now you are covering the second row still and the second column. We will have lambda minus 1 negative 3 negative 3 lambda minus 1 minus, thirdly we have negative 2, and now we are covering the third column. So we will have lambda minus 1 0 minus 3 0. So you'll realize that from our choice we'll just be left with 1. Everything else goes to 0. So our first value here will be 0, and then also lastly here we will get a 0. So we will be left with only 1, which is lambda minus 3 into that determinant. You can see it's a 3 by 3 matrix. We're going to get lambda minus 3 into lambda minus 1 squared minus 9. Let's use the curly bracket so that we can easily differentiate, is equals to 0. You can see clearly that as we are going to simplify here, we have a difference of 2 squares. So instead of going the long way, we'll just use that difference of 2 squares. Lambda minus 1 squared is a square, and 9 is also a square. So this gives us lambda minus 3. Then we will have lambda minus 1 minus 3, and now we have lambda minus 1 plus 3. Those are the two squares. So and everything here is equated to 0. So we will have lambda minus 3 into brackets lambda minus 4, and we also have lambda plus 2 is equals to 0. So our eigenvalues will be 3, 4 and negative 2. We can go ahead and get the eigenvalues. We have the eigenvalues. We can get the eigenvectors. Tune in shortly in the next video as we get the eigenvectors. Thank you.